Hello and welcome. So in this video I'm going to show you guys how to make a regression model by using the keras library. So this is basically a deep learning topic, and if you guys want to the tutorial on a deep learning, basically basics of the deep learning, I will give a tutorial for you guys. Okay, so start this project. So first of all, what we have to do, we have a data set about the cements, and there are several attributes like a furnace and so on. So just take a look of a data set. So for this, first of all, we have to load some data analysis libraries, that is pandas and numpy. So for this, open your Jupyter notebook and start coding. Okay, so first of all, you have to import the pandas library. For this, you just take import pandas as pd, and after that you have to import numpy library, that is import numpy as np. Okay, so run it and it is successfully loaded. And after that, what you have to do, you have to just load your dataset by using the pandas read underscore csv methods. For this, just take a variable name, that is data, and in that variable name just use the read underscore csv function, and inside code just provide the data set url. Okay, so this is the data set that is freely available on a cognitive class, so I will provide a link in the description, you can download from there. Okay, just remove these codes. Okay, this one. Okay, sorry. Okay, now it's okay. So just shift plus enter. Okay, so as you can see, our data set is being loaded, and if you want to check whether it is correctly loaded or not, just use the head method. So for this, just data dot head method, and you can see the above 5 rows of your data. So you can see the attribute, that is cement, blast furnace, slag, fly ash, water, superplasticizer, coarse aggregate, fine aggregate, and age, and the last one is strength. So there are total number of 1 3 4, and those, so there are total 8 parameters are there, or we can say attributes are there, and we are going to perform the regression model that is basically used for the prediction. So we are going to predict the strength of the cement by using the other remaining 7 parameters, that is cement, blast furnace, and so on till the age. Okay, so the remaining 7 parameters will use as the predictors, and the strength will be our target variable. Okay, so this is just a load our data set, and in the next step we are going to take a quick look of our data set. So just take how many rows are there and columns and so on. So for this, just use the shape method, data dot shape. Okay, so as you can see, there are 1030 rows, or we can say the number of entries, and 9 attributes are there, and 9 is why, because 0 to 1030 indexing are there. Okay, so just take a quick analytics out our data set by using the describe method. So for this, just data describe, we can see, so it will take some time because the data is loading. Okay, and so on. Quick. Okay, what's going on? Let me check my network issue. Okay, so it's run perfectly. So as you can see, the total number of count are as total number of the rows. Okay, so if we see the mean of the cement, so there is 281 point and so on, and if it mean age of all the data cement that are available in a data set is approx 45 years, and the standard is approx 35, and standard deviation minimum 25 75, quartile range and so on, you can check by using a describe method. So it is best suited for getting the quick analytics on of your data. Okay, so this is a describe method, this is shape and so on. So what we have to do in the next step, we will check whether there is any, we are going to perform the data cleaning. Okay, so for this we have to check whether there is any null value present in this data set or not. So for this we are going to just perform is null operation. So data dot is null and after then just take a sum. So if there is null, so it will, okay. So as you can see, our data set is quite clear and there is not any null value. If there is possibility of null values, you will get the values in the place of 0, 1, 2 and so on. So for removing the null values, you just use drop NA function. Drop NA, not function, drop NA method. Okay, so this is all about quick analysis on our data set. So what we have to do in the next step, so this one is done, this one is done, this one is also done. So what we have to do in next step, we just split our data into the predictors and the target variable. As I told you guys, there are 8 variables are there, or we can say 8 parameters are there, but for the prediction 7 parameters will be used and for getting the target values. Okay, so for this, now I'm going to splitting the data set into the predictors and the target. Okay, so for this I'm just going to take a variable that is predictors, so you can see predictors. Okay, so running quite well. So predictors, and after then, I'm going to take all the data columns. So first of all, just make a variable that having the column name. So for this data underscore columns, and it will store all the columns of our data. Okay, so after them it will, okay, so just take a variable predictors, and this will take all the column name except strength, that is because strength is our target value. So okay, so from data just take data columns, and from data columns just remove or just ignore, just not take strength, strength. Okay, so if we run this student refactory, oh, so there's another, data columns are not defined. So what is the problem with this? Data columns is not defined. Oh, this one is spelling mistake, COL. Okay, so it's run successfully. So this is our predictors. Or if you want to check the predictors, so just type predictors, and after then just use head method. Okay, so it will show guys the remaining 7 attributes, and you can see there is not strength available. So as strength is our target, so for getting the target, just use the target, and inside this just choose data columns and their target, that is our strength. There's an error. Okay, let me check. Okay, so data columns, and again, there's some error. From data, let me do this again. Okay, data underscore columns, data to take strength. I hope it will run now. Oh, there's still an error. Oh, let me check what is the error. Okay, and so so we don't need to use the data column, just use the data frame name, that is our data, and just take the strength. Okay, and here strngth. Okay, so now it's run successfully. Okay, so what we have to do in our next step, So we are going to just perform normalization on the predictor. So the formula for normalization is just the variable minus variable mean divided by the standard deviation. So for this we are just going to use a variable that is pre-norms, that is for the predictors normalization. Okay, so what is the formula? As I told you guys, the formula is predictors minus predictors mean. So mean is a function that will return the mean of predictors of that variable, and divided by the predictors standard deviation, that is STD. Okay, so if I run this, it will run successfully. And now if you check the normalize predictors, you can use this one. Okay, so as you can see, our predictors are normalized and the values will be like this. Okay, so this is the normalization done, and in the next step what we have to do, the most awaiting part, that is performing regression model by using the keras library. Okay, so for this, so one step is remaining, that is for the get the number of predictors. Just take a variable name and store the number of predictors that we use for building our neural networks. Okay, so for this, just take a variable name that is n underscore calls, basically the number of columns. Okay, so for this we just do the predictors and just take the normalization variable. Okay, that is pre-norm, and in this we just perform shape. Okay, shape, and inside this we just run 1. Okay, if I run this, it is run successfully, it is running successfully. Okay, so what we have to do in the next step, we just build our neural network. So for this, first of all, I would like to tell you guys the keras is a library that is used in a TensorFlow. So if you are using Jupyter Notebook in any other platform, just first of all make sure you import the TensorFlow. After then you from TensorFlow you import the keras. Okay, so I'm using the IBM Watson Studio, so there is TensorFlow is already imported, so I just use the import keras. Okay, so for you guys, first of all import TensorFlow, and after then go for import from TensorFlow, import keras, or you can directly use the import tk.keras and so on. Okay, so import keras, and from keras models, import, there are two models in a keras, that is sequential and a class. So class is used for the function and API, so we are just performing the sequential neural networks on the regression, so just use the sequential. Okay, just import sequential. Okay, so in the next step what we have to do, just from keras dot layers import dense, because our neural network consists the hidden layer as well, so it is quite good if we import dense as well. So this is, let me check it is running or not. As you can see, using TensorFlow backend, so that is the specialty for the Watson Studio. If you guys want to know how to access the Watson Studio for the AI and the machine learning, just drop a comment, I will make a separate video on that. Okay, so this is done for the loading, or we can say importing libraries. So what we have to do in the next step, so in the next step we are going to just perform the building of neural networks. So for building the neural networks, so I'm just going to create a function that is the regression, because we are just performing the regression operation, and inside this I will add all the layers for the neural networks. Okay, So first of all, define a function that is regression. You can name it as you want, this regression, and inside this just take a model name as we take, that is sequential. Okay. And after then just add layers step by step. So for the first layer it will take input, so make sure you provide input shape as well. That is nothing but our calls, that is n calls variable, the number of columns for the input shape. Okay, so for this just use a model dot add, and inside the bracket just use the dense, and just you can take any number. I'm just going to take 50. Okay, you can take anyone. It is nothing but just some working chain of the neural networks, but output will be same. Okay, 50. And for the activation function, there are number of activation functions are there, but when we deals with the hidden layers, so it is quite good if we use the RELU, that is RELU, as an activation function. Okay, so for this RELU, that is RELU. Okay, so in the next step just use the input shape, that is nothing but the variable that we define above, that is n calls, and comma, and okay, it is done. I think it is done. Okay, so in the next step, this is our first layer. As you can see, in the first layer we just provide the input as well, and all the hidden layers, the input for the hidden layers is come from the first layer. Okay, so from the second layer we don't need to provide any input. Okay, so model add dense and 50. Okay, and after an activation function, activation. Okay, activation. What is the problem with this? This one, activation, and again RELU. Okay. And this one is for the hidden layers, and the last one is for the output layer. So for output layer we don't need to specify the activation function, so just add, and inside this provide the dense and 50. Okay. Okay, so our model is, so there's not 50 layers in output. Output is only one variable, so it should be 1. That is for the strength of the cement. Okay, so what we have to do next, this is the model building, and in the next step we have to just compile this. So for this I'm going to use the model dot compile, and inside this we just use an optimizer. So when we talk about the optimizer, so there are number of optimizers are there, like Adam, gradient descent, and so on. So Atom is useful by working in neural networks because it is automatically work with the hidden layers, and there is no need for any processing. Okay, so for this I'm going to use the optimizer. Okay, optimizer, that will be Adam, and after then loss. For the loss we just take Okay, so for the loss, we just take the mean squared error, okay. So after then what we have to do, we have to just, so it is done, we have to just return our model, so that is return model, okay. So let me check, is there any error? Okay, so there is an error, that is something, positional argument follows keyword, okay. So for this just use, okay, I just missed the equal sign in the input underscore shape. So after then, after input underscore shape, just provide the equal sign, okay. Okay, just provide the equal sign after input underscore shape. So I hope it will run successfully. As you can see guys, it is running successfully. And what we have to do in the next step, our model is done, and in the next step we are going to just fit our model. Before fitting our model, we have to make a variable that is model, and inside this we just use the output that will written by the regression function. So by using this, there's some error with the spelling, okay. So regression, okay. So as you can see, it is running successfully, and in the next step we are going to train our model on neural networks, and for this we are going to just use the 70-30 ratio for training and testing, okay. So this is done, this one is also done. So for this we can directly use the model.fit method, and inside this we just provide the predictors norm variable, that is nothing but normalization of our predictors, and the target value, that is the strength of the cement, okay. So after then what we have to do, there are basically two methods. So this one is done, so we are going to just perform validation by 30-70 ratio. So for this we are going to use the validation underscore split and perform and provide 0.3 value inside this, okay. So after that, this one is also done, this is also done. What is epochs? So what is the epochs? Epochs is nothing but the number of times that our neural networks train. So when I run this code, you will see our neural networks train till the 100. So if you can use 200, 300, 400, so on. It will take some time, but how many times you use higher value of epochs leads to the higher accuracy in your neural networks, okay. So what is the verbose, and inside this we will provide the verbose too. So I would like to tell you guys, verbose are basically three types in keras, that is 0, 1 and 2. 0 is for the nothing, 1 is for the whenever you see any loading, so that dot 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 are the nothing but the verbose one, and verbose 2 you will see when this one is running, okay. So let me run this code guys. So there's an error, so what is the error, let me check. So unrecognized keyword arguments epochs, okay. So in the place of epoch we have to just use epochs, s is missing, just use s, okay. So when I run this, as you can see guys, our model is running successfully, and it is the 1 out of 100, and it will run till the 100 out of 100, and these epoch 9 out of 100, 10 out of 100, these notation is just come by using verbose 2, okay. So that's how our model is running. So you can use this model for the prediction. Just take a 2D array, inside that array just provide all the values for the attributes, and just use the model.predict method to predict the value of the strength of the cement, okay. So I hope guys you like this video, and this is basically the neural network, how to train a neural network by using the keras library with the Python, and this is on the IBM Watson platform on a Jupyter notebook. So if you want to run this project on any other Jupyter notebook like Anaconda environment or the Azure on the Azure platform and so on. You can use this, but I would like to tell you guys in IBM Watson platform. Oh, what is this? Okay, so in the IBM Watson platform, the TensorFlow is already running on backend. So if you are using any other platform, so make sure you import TensorFlow first, and after that you just from TensorFlow import keras. Okay. So I hope you like this video. If you like this video, just thumbs up and share with your friends. I will provide my GitHub code for this video in a description. You can download from there. It's okay. So thank you so much for watching this video. If you found this helpful and so on, just share with your friends and subscribe my channel. Okay, so thank you.